Welcome to Saurabh Sir classes. Today the tutorial is on microeconomics. We will be focusing on the topic marginal rate of substitution. In case of any query, you can contact us on this particular number, and our mail ID is saurabhsirclasses@gmail.com. So problem 1 of marginal rate of substitution. In this particular problem, we can see there are three functions given to us, and we have been asked to find out the partial derivatives, then to find out the marginal rate of substitution, and given a value we need to calculate the marginal rate of substitution. Don't get scared looking at so many columns and row. It's very simple. We just require to perform simple calculation. So let us start with the first utility function, which is in terms of a product form. Okay. So this is our utility function. So let us start with the partial derivatives. So del u by del x1 will be simply x2, and del ux by del x2 will be x1. So these are our partial derivatives. Now marginal rate of substitution. Now before going into this, first let us see what is this. So marginal rate of substitution is the rate at which one good is exchanged for another. So you are just exchanging the goods, and the rate is the marginal rate of substitution. So there lies concept of exchange. Okay, or a kind of, you can say you're trading. So don't get into all those tough words. So we will stick to exchange. Okay, and that exchange rate is nothing but the marginal rate of substitution. So marginal rate of substitution has a particular formula. So this is the formula, that is the partial derivative of one good by the partial derivative of the other good, and in the beginning there will be a minus sign. Okay, so yes, so there will be a minus sign to this. But why there is a minus sign? Because in order to get 1 unit of A, you need to give away some units of B, and this what's explain the negative sign. Okay, so what will be this? So let us substitute these two values in this particular formula. So we have minus x2 by x1. The last column is we need to determine the marginal rate of substitution at the combination 2 and 3. So just in place of x1 we will put 2, and in place of x2 we will put 3. So x2, so it will be minus 3 by 2. So these will be our answers, or the answers to our first row. Moving on, let me now insert an extra page for you guys. Now let us perform the same exercise with regard to the other two functions. Now in the function number 2, we have the same product form, but in this case we have pass. Okay, now we will start with the partial derivative as we have done before. So this will be 3x1 square x2 to the power 5, and the other will be 3x to the power x2 to the power 4. So we simply write this by substituting. We can get marginal rate of substitution by simply substituting these two values. So let us do that. And this will come as 3x square by 5x1. Now in place of x2 and x1, we will just substitute the value 2 and 3, and then we will get minus 3 into 3, that is x2 values, and 5 into 2. Okay, so we'll get minus 9 and 10. So minus 9 by 10 will be our answer. Moving on to the third and the last function which we have. So finally we can say that this and this will be the answers or will fill the second row. Now the last function, this is in addition, and we have log also, natural log. So let us do it. So del u by del x1 will be 3x1, and similarly this partial derivative will be this. We substitute these two values in this particular formula and we get and again for deriving marginal rate of substitution at the combination 2 and 3, we will substitute 2 for x1 and 3 for x2, and we will get the values. And the answer again is 9 by 10. So this, and this will be our answers to the last column. Now we move on to the second part of the question. Now in question number B, we have the same utility function which was provided to us, and they have asked you that using this particular function we need to interpret the marginal rate of substitution at this particular point. Okay, so first let us do it in parts. First we will perform this part and then we will move on to the rest of the question. Then we will answer the rest of the question. Okay, so this is our utility function. In the previous case we have already derived the marginal rate of substitution. So what is the interpretation? The interpretation is add bundle to 2, 3 which is given to us to remain at the same level of utility. A consumer is willing to give up 9 by 10 which we have already calculated of x2 for one additional unit of x1, that is good. One. Okay, so this will be our interpretation. Now next I have asked you, is good 1 more or less valuable than good 2? Now the answer to this particular question lies in the marginal rate of substitution itself. Okay, so we know that the marginal rate of substitution is minus 9 by 10. So at point 2, 3, since we need to get less of x2, then he means the consumer itself, of the other good x1 to remain as satisfied, we can say x2 is more valuable than x1. Now we move on to the third part. That means how much of good 2 would have to give a consumer after taking away 0.00001 of good 1. So if 0.00001 of good 1 is taken away, he requires, you take the amount of good 1 you are taking away and you get the marginal rate of substitution. So you multiply this and then you will get .0000009 units of good 2. Okay, and this has to be done so that the level of utility for the consumer remain unchanged. That means at point 2, 3, since he need to get less x2 than he lost of other good to remain as satisfied, we can say x2 is more valuable than x1. And if 0.00001 of good 1 is taken away, he requires 0.00009 units of good 2 so that the level of utility for the consumer remains unchanged. So this is the last part of this particular sum. Now before starting the sum, first let us define something. What do you mean by monotonic? Now when we say monotonic is something which is entirely, either it is entirely non-decreasing or non-increasing. Now this particular definition is very confusing to you. So you can understand whether to find out, if you want to find out whether a function or particular function is monotonic or not, you have to look at its first derivative sign. You will derive its first derivative. You will derive its first derivative and you will concentrate on the sign. If the sign does not change, then it means it is monotonic in nature. Okay? Now having said that, let us start with the problem. This part says that knowing log x is a strictly increasing function and this takes the form, this particular function takes the form this, explain why marginal rate of the function in the last two rows in the table coincide. So we have seen previously that for the last two functions, the marginal rate of substitution, if you remember, was 9/10. So they are asking the question why it is so. The answer is because one is the linear transformation of the other. That means this particular function is the monotonic transformation. Let me write monotonic transformation of this. So let us see how we can say this. So to see this, let fu is equal to log u, where letting u is equal to this. So if now I'll substitute this here, so fu will be log of, in place of u I am writing this x1 cube x2 to the power 5. Now so fu becomes a monotonic function. Okay, now here we can, this can also be written as, how it is a monotonic function, let's see. Using the simple rule of log, we are writing this, and this is nothing but this. So we can easily say that this function, this particular function, is the monotonic transformation, of this particular function. And that's why, because in monotonic functions, the ranks of the bundle are preserved. MRS will be the same. That is minus 9/10. I hope this tutorial was helpful to you guys. And in case of any queries, you can contact us on our contact number on the email ID provided to you. We will reach out to you as soon as possible, and thank you for watching.